Hello and welcome. Today, we're taking a tour of the most essential piece of public infrastructure you've probably never inspected, the cardiovascular system. We're going to look at how it all works, not as a biological process, but as the ultimate highway network. Right, so we're not going to be looking at this with the eyes of a biologist. Not today. Instead, let's approach it as engineers and, well, as public health managers. Let's view it as the ultimate national infrastructure, a truly remarkable system of transport, logistics, and emergency response that keeps a population of trillions of cells not just alive, but thriving. So, let's kick things off with the big picture. Before we get into the vehicles or their cargo, we really need to understand the vast network of roadways that connect every single part of the body. What you're looking at here is essentially a map of those roads. The red arteries, they're like our motorways, carrying traffic at high pressure away from the central hub, that's the heart. And the blue veins, well, they're the A-roads, bringing all that traffic back again. And right at the center of it all is the heart, working non-stop, a relentless pump making sure there are absolutely no traffic jams. Now, here's where it gets really interesting. What is actually traveling on these roads? The traffic itself is incredibly complex. So let's do a spot check. Let's pull over one of these vehicles and inspect its cargo, the blood. So the average adult has about 5 liters of blood. And if you take a sample and spin it in a centrifuge, just like you see here, it separates out. It's a brilliant way to see that blood isn't just one substance. Oh no, it's a really complex mix of liquid and solids, where every single component has a very specific job to do. You can see that over half of it is this straw-colored liquid called plasma, and that carries everything from hormones to waste products. But look at the rest of it. Almost 45% is made up of specialist red blood cells. And then there's this tiny but absolutely vital fraction, less than 1%, made up of white blood cells and platelets. These are the real key workers of the system. Okay, so let's start with the most numerous of these specialist vehicles, the ones that are responsible for the single most important delivery in the entire body, the red blood cells. Honestly, the best way to think of red blood cells is as a massive nationwide fleet of delivery lorries. They are completely single-purpose vehicles designed for one vital job, picking up oxygen from the lungs and getting it delivered to every single tissue and organ. And they are just masterpieces of logistics design. I mean, look at them. Their dimpled, biconcave shape lets them squeeze down the narrowest country lanes, our capillaries. They don't have a nucleus, no engine, not even a driver's cab. They've literally been stripped of all non-essential parts to maximize the cargo space for their precious payload. Hemoglobin, that's the molecule that actually grabs onto the oxygen. And the sheer scale of this logistics operation is, well, it's staggering. In just a single, tiny drop of blood, there are 500 million of these delivery lorries, all working tirelessly around the clock. But, even the best-run infrastructure faces threats. So what happens when the network is invaded by pathogens, or a road is breached by, say, a pothole or a cut? Well, that's when the emergency services get scrambled. This rapid response team is made of 2 key groups. First up, you have the white blood cells. They act as the body's police force and a kind of multi-agency emergency service. And second, you've got the platelets, who are the dedicated 24/7 highway repair crews. Now, this emergency service isn't just one unit. It's an incredibly diverse and highly specialized force. We're talking everything from the Bobby on the beat all the way up to highly trained counterterrorism units, each with a very distinct role in keeping the peace. The first to arrive on the scene of any incident are the granulocytes. Think of neutrophils as the frontline police. They get there, they trap, and they neutralize the pathogens. Eosinophils are a bit more specialist, dealing with particular threats like parasites. And the basophils? Well, they're the ones sounding the alarm, releasing histamine a bit like a siren to call for backup. Then you've got the agranulocytes. These are the highly specialized intelligence-led units. The B lymphocytes are like the intelligence agency, creating antibodies, which are basically blueprints for known criminals. The T lymphocytes? They're the armed response unit, tasked with taking down compromised cells directly. And the natural killer cells are the constant surveillance patrols, always monitoring for and controlling the spread of internal threats. And while all that's going on, what about damage to the roads themselves? When there's a breach in the network, a simple cut, the highway repair crews, the platelets, are instantly dispatched. These tiny cell fragments just swarm the area, sticking together to patch the damage, stop any traffic leakage, and allow for permanent repairs to begin. It's amazing. So we have this unbelievably complex fleet of vehicles and personnel, which of course begs the question, where are they all manufactured? Where do they all come from? Well, the answer lies in a process called haematopoiesis, and it all happens in one central location, the red bone marrow. This is the body's ultimate factory floor, its training center, and its vehicle depot, all rolled into one. Inside this factory, a single, remarkable type of stem cell can be directed down one of two main production lines. You've got the myeloid line, which produces our delivery lorries, the repair crews, and all the first responders. And then you have the lymphoid line, which is dedicated to producing those highly specialist intelligence and tactical police units. And this is the absolute genius of the system. Every single cell we've talked about originates from this one type of master cell. This incredible flexibility means a factory can respond to real-time public demand, ramping up production of oxygen lorries when you're exercising or deploying more police units during an infection. And the production rate? It is simply immense. This factory manufactures around 200 billion new cells every single day. That's what it takes to replace all the cells that have been damaged, have grown old, or have been destroyed in the line of duty. And this really is why, from a public health perspective, understanding this system is absolutely critical. Because when this vital public service fails, the consequences are severe. A shortage of those oxygen lorries leads to anemia. An uncontrolled production of faulty police units is leukemia. A lack of repair crews causes bleeding disorders. The whole system has to work in perfect harmony. Which brings us to a final thought. We've just toured the body's own self-regulating public health and emergency service network. And seeing just how complex and vital it all is, well, it prompts a crucial question for those of us who work to protect public health. What is our role in maintaining and supporting this incredible infrastructure within?